12.1 is our basic probability lesson. Okay, we're going to do a lot with probability throughout this chapter, but 12.1 is all the basics. So, you know, like back in middle school, you would have had a probability chapter, and you would have spent several different days on probability. We're putting those all into 12.1. Okay, so this is just all of your basic probability before we go into some other pieces here. So the question that we're kind of thinking about through 12.1, our thought here is, how does describing events as mutually exclusive or independent affect how you find probability? So today we're going to be talking about what it means to be mutually exclusive and how you find those probabilities. As we go through later, tomorrow we'll talk about independent events and what that means. Okay? So we're going to start kind of basic here. Find the probabilities of these mutually exclusive events. And we'll talk about what that means at the end, but you roll a standard number cube once. Let E represent the event that you roll an even number. Let T represent the event that you roll a 3 or a 5. A. What is the probability that you roll an even number or roll a 3 or a 5? So note, there's the word or in there, yes? Okay, so when they talk about probability you roll an even number or roll a 3 or a 5, in terms of how they define things, they're asking the probability that you event E happens or probability that event T happens. Because E was rolling an even number, T was rolling a 3 or a 5. Okay, so sometimes they use the word, sometimes they use it in terms of letters there. Now, I'm going to go very basic. If I use this circle to represent event E, event E was rolling an even number. What are the possible outcomes for event E?
50%.
No.
2, 4, or 6.
2, 4, or 6.
Oh.
You could roll a 2, you could roll a 4, you could roll a 6 for event E, correct? What about T? What are the possible outcomes for event T?
3, 5.
T was rolling a 3 or a 5, so this is a 3 or a 5. Now, we want the probability of E or T, which means we're going to break this into two pieces. What's the probability of E happening? The probability of rolling an even number, 2, 4, 6. He said 1/2. Where did you start at? As a fraction?
3 out of 6.
3 out of 6 is where you started at. I'm not against 1/2. I'm just trying to save myself work later. What about the probability of event T happening?
2 of 6.
3 or 5 is 2 options. And we're saying 2 out of 6 because it's, we all know a die is 6 sides, right? What do we do with these? We're going to add them, okay? Now, the hint I'll give you, I can't use the word all. Majority of the time when you see the word or, guess what? It's going to turn into an adding event, okay? And we're going to talk about, but these are mutually exclusive events. These are events that cannot happen at the same time. You can't get a 2, 4, or 6 and a 3 and 5 on the same roll. Okay? One or the other could happen, but you can't get both. What is 3 6 plus 2 6?
5, 6.
5 6. Which is the only reason I didn't write down the answer of 1/2. Because I knew where this was going. Okay. Now, look at this change up. What is the probability that you roll an even number and a 3 or 5? Okay. Now, I'm going to change up my diagram a little bit. We have event E. And we have event T. Looks like a diagram you've probably seen somewhere along the line, I'm guessing, right? keep in mind, event E, what did event E have in it? It was our evens of 2, 4, 6. Event T was rolling a 3 or a 5. What goes in the middle?
1. Nothing.
Is there anything that overlaps between the two groups? There's not, is there? Okay, there's no 2, 4, 6 falls in event E. 3 and 5 falls in event T. There's none that can go in the middle and share the circle, are there? So, with that in mind, we're being asked about the probability of E and T. What would you say here? 0. Because how many options fall in here in the middle? And that is 0, right? There are 0 numbers that overlap. So 0 out of 6 if you want, which is just 0. Okay? And this is, in this scenario, you're rolling a standard number cube once. Okay, so the fact that if you just roll it that once, you can't get a number that's even and the 3 or a 5. And one more change up. C. What is the probability that you do not roll an even number? Okay.
30 of 6.
50%, 3 of 6, because?
Because 1, 3, 5 are odd numbers. And
Okay.
2, 4, and 6 are even. So if
Okay.
you roll it, then get 50-50 chance.
Okay. You can also look at it as if there's 3/6 chance of even, then that means the other 3/6 are not even. So if I say the probability of not event E, you can indeed say 3/6, but you would never leave me an answer of 3/6, would you? Okay. If we're in the fraction world, you'd go 1/2, right? Okay. That's kind of some basic probability, right? Definitely goes past what basic probability was when you first learned probability, but that should be pretty basic knowledge to you. So a definition of mutually exclusive here. Mutually exclusive is when two events cannot happen at the same time. The events are mutually exclusive. If A and B are mutually exclusive events, it's the probability of A or B, and you just add the probability. So probability of A plus B. Another definition here, favorable outcomes. An outcome that is being tested or observed, but not necessarily a desirable result. So, basic probability knowledge, the probability of an event. You're going to do on top the number of favorable outcomes over the number of total possible outcomes. Okay? Okay. Continuing along. Let's go talk about this box of 100 balls. A box contains 100 balls. 30 of the balls are purple and 10 are orange. If you select one of the balls at random, what is the probability of each of the following events? So the first one, the ball is purple or orange. So we want to know what is the probability that the ball is purple or orange. What do you say?
40%.
Okay, work me there, because I don't want a final answer. I want work, guys.
30 plus 10 equals 40, and then 40 divided by 100 equals 0.4, and then you move the decimal point over 2 times the percentage.
Okay, so I'm going to go about this in pieces, but yes, okay. 30 of the balls are purple, so what's the probability of getting a purple ball?
30
Go fractions to begin with, guys, okay? Don't jump all the way to percents. Go fractions. I need everyone with fractions.
30 out of 100.
Okay. 0.4 plus, what's the probability of an orange ball?
10.
10 out of 100. And we know that 30 out of 100 plus 10 out of 100 is
40.
40 out of 100.
See, 40.
Now, you wouldn't leave me an answer of 40 over 100. What would be the first way you would express this? The first way you would express this.
No, she said fractions. 3%. 4%.
Keep going.
2 or 5.
Okay. So 40 over 100 is fully reduced. I mean, we could say, what? We went through 20 over 50, 4 out of 10, 2 over 5, 2 over 5, final result. What are other ways to express 2 out of 5?
40%.
Okay. 2/5, when you divide it, is 0.4 as a decimal, or 0.4 as a decimal is 40%. Now, all three of those answers are acceptable depending on the scenario. Okay?
Do we have to show that?
I will tell you. Can you let me talk? Okay? I will tell you that Savas is mostly going for fractions and decimals. If they want a percent, they will clearly say a percent. But if they don't say percent, they want fractions or decimals. Sometimes they are very specific. I will be honest, there are times that I went and tried it both ways because I was curious. They didn't really specify and they accepted either a fraction or a decimal. Okay, so just kind of pay attention. But there are multiple forms possible. Okay? Now, let's turn this around. The first probability was the probability that the ball is purple or orange. The second one is that the ball is not purple and not orange. There's different ways we could talk about this. What's the easiest way to talk about this?
So 40, right? There's 40 balls total of the colors. So you get 40 or 100 minus 40. And that gets you 60. And that's 60 over 100. And then after that.
Okay, just pause there. The 60 out of 100 makes sense.
Yeah.
Okay, it's the idea that 40 out of 100 were purple and orange, so the remaining parts are not purple and orange. Now, I'm going to throw out the idea, because we're talking probability, of thinking of this as 1 minus 40 out of 100. This is basically the same thing Raja did, just hang with me here. Because 1 represents what? 100%. It represents all of them, right? It represents the entire probability. So in that case, you can think of 1 as 100 over 100 minus 40 over 100, which is indeed the 60 over 100. Okay, I need to throw that idea of 1 in there so you can be thinking about that. Not that there was anything wrong with how you guys were thinking about it. What are ways to express the answer of 60 over 100?
6 over 10.
Okay. As a fraction, it fully reduces to 3/5. As a decimal, 0.6. As a percent, 60%. Okay. So again, they're all good probability answers, depends on the scenario. Okay, with that in mind, okay, a little bit of vocabulary at the bottom here. If A and B are mutually exclusive events, in other words, they don't overlap, then the probability of doing A or B is going to be the probability of A adds to the probability of B. Now, we saw this up above on one. The probability of A and B, this is if they don't overlap. This is like the probability of event E and event T up above is 0 when there's no overlap. And then what we just talked about is we just talked about the complement of an event. And it's a set of all outcomes in a sample space that are not included in the event. So what we just did there, we did the probability of not orange and not purple. We could do 1 representing all of them minus the probability of it happening. And so you'll see 1 minus the original probability there. Okay, so all good things to think about here. Questions before we turn the page? Am I still kind of in the basic range?
Yeah, definitely.
Very basic?
Very basic.
Okay,
Very basic.
I will move on then.
Yeah.
Okay, I'm going too slow is what I'm hearing.
Yes.
Okay, well, they provide us a picture on this first one. A student-made target includes 2 overlapping squares. Assume that a sticky ball is thrown at the target and it's equally likely to land anywhere on the target. What's the probability that this ball is going to land inside one or both of the squares? Okay, what kind of information are we going to have to find here?
How many square centimeters the target's squares take up out of the whole thing?
Okay, so when he's talking about how many square centimeters that the squares take up, we're talking about finding area. Okay, when you're asked to do probability in this scenario, we're finding area. So, what areas, before we go and put this mathematically into probability here, what areas do we need to know?
The area of the whole thing, the area of each triangle, or not triangle, square, and then the area of the overlapping square in the middle.
Okay.
Which is the area of the overlapping square in the middle just a fourth? Well, I guess we can't assume that.
Depends on what you're saying a fourth of.
A
So,
fourth of the little square.
of one of them.
Okay.
Okay, let's talk first of all, and I'm just going to kind of write down some information. What's the entire area? Like this entire area of the whole big thing. 1,200 square centimeters, or centimeters squared, because it's 60 by 20, and we know 60 times 20 is 1,200 square centimeters. Are we okay with that? Okay, let's talk about square A. What do you know about square A? It's 10 by 10. So square A has an area of 100 square centimeters. Okay. What about square B? Square B, the blue square on mine, is also 10 by 10, right? So it is also 100 square centimeters. What's the other piece we have to talk about? That little overlapping square, right? So I want to talk about, what about the overlapping area of A and B? Okay. It's in there and it's showing as a 5 by 5. So that piece right there in the middle of 5 by 5 is going to be a 25 square centimeter piece, right? Okay. So I would say that that's pretty much all the answer, all the information we need. Now, I'm not going to find the probability quite yet. But let's just talk about A or B. If we're looking, eventually we're going to be looking at the probability that the sticky ball lands in A or B. What does that look like in terms of numbers? And I'm not talking probability yet, but I want to talk about that 200 number. I don't fully agree with the 200 number.
Because of the overlap, you have to subtract the overlap.
Mine was 25, so 175.
Okay, so the idea that A is 100 square centimeters plus B is 100 square centimeters. So that's 200 square centimeters, right? But does the sticky ball have 200 square centimeters to land in? No, because there's that overlapping corner, right? And that overlapping corner, we only want to count it once, so we need to subtract off 25 square centimeters. So A or B has an area of 175 square centimeters. Okay. So now, now I'll talk probability. Probability of the sticky ball landing in square A or square B. What are we doing here?
That's
175 over 1,200, which is the entire area. Okay. Give me a better answer than 175 over 1,200.
90%.
Not yet.
What's
As I said, Zabas isn't going to go for a ton of percents.
35 over what?
240. 35.
Okay.
7
35 over 240 can definitely keep going.
7 over 40.
Okay.
Oh
Now, folks, I will tell you, most of your calculators can simplify fractions. If you put it in as a fraction with, like, on the TI-84s with the A over B button and just hit equals, your calculator will simplify it.
Where's the A over B button?
over BC, A over BC.
Yeah, something like that.
Where's that, Raj?
Just look for it, Thomas. Use your eyes,
Has
buddy.
it-
Oh, wait, is this it?
Yeah, the ABC button, A and B over C.
Do you click it first and then you type in the number?
So type in, let's see, you would want to type in 175, hit your ABC button, 1,200, and hit equals.
Oh, what? There's no way, bro. What?
That would have been so helpful.
You gotta show us like all this stuff.
Yeah, you need to do like the first week of school. You just need
Yeah,
to
you
show us
need-
all the calculator tricks.
First
But I
week
can't
is
really, I mean, they make more sense when they come up.
what the heck?
So,
The line is in it too.
I could have been using this back in middle school.
That is nice.
Oh my.
know how to use
You
your
remember?
calculator.
You remember how they would ask
Okay.
you on problems too, right?
Yeah.
Oh man.
You would have been cheating. I'll get
Okay.
that to 6th graders, bro.
So play around with your fractions, I guess. Now, so 748 could be a fraction answer. What is this as a decimal?
Oh, 14.6%. Oh, 1.1458. Some. Doesn't matter.
Now, on my notes, I'm actually rounded to a whole percent.
15.
So if we round this to a whole percent, it's approximately 15%. This is one where I could see Savas wanting it as a percent. I don't know for sure, but this is one I could see them wanting it as a percent. Okay. Now, let's talk about the probability of whether the starship succumbs to the black hole. That's next. A video game screen is a rectangle with dimensions 34 by 20. A starship on the screen is made of two circles with radius 6 centimeters and overlapping area of 20 square centimeters. A black hole appears randomly on the screen. What's the probability that it appears within the starship? So I see this as what's the probability that the starship is going into the black hole is what, you know. Okay, now, downfall? No provided picture here. Not saying you'd have to draw a picture on this one, but I'm the teacher, this is a note, so guess what I'm doing?
Oh.
I'm drawing a picture. What am I drawing?
That's a starship. A rectangle and then a giant starship.
A rectangle. What do we know about said rectangle?
It's 34 by
34 by 20.
That's a small screen.
Okay. And the starship is made of two circles. With radius 6. And overlapping area of 20 square centimeters. Okay. Now, some information we should probably find before we proceed. What information do we need to find?
Area of the circle, which is what 2 pi r.
Okay. So,
You ever heard of that?
let's talk about each circle. So, what's the area formula for a circle? Pi r squared. As sophomores and juniors in Algebra 2, you need to know that formula. We won't talk about the fact that I get calc kids that can't remember that formula, but folks, that's something you should just know as a math student at this point in your life. So now, we're not going to use the calculator to do this. In other words, we're not using the pi button. Pi r squared. So what do we know about the circle? Has a radius of
Oh, 6.
6. Has a radius of 6. So if it's pi times r squared, it's pi times 6 squared. Pi times, what is 6 squared? 36. So I'm going to say that each circle has an area of 36 pi. Could you multiply into a decimal? You could. But it's just going to make your answer less accurate in the end. So we're just going to say that each circle has an area of 36 pi. Hold that thought. Okay? And then what other area? We already have the overlapping area. A circle is 36 pi, and we need to know...
Oh, the rectangle's area.
Yeah, the entire area.
It's 20 times 34, which is 685.
And that would be 680 square centimeters. I guess all of these are square centimeters. Okay. Okay, I would say we have all of our information that we need. With that in mind, can we start by talking about the starship? Because that's the hard part, right? So let's just talk about the area of the starship. What do we know about the starship?
36 times 3.14 minus. Wait, do you subtract the area or do you add it? I think it's. I don't know. You probably. Okay, so you do that number, right? And then you multiply by 2, and then you add that number on top of the multiply by 2. Or no, probably not.
Okay.
Probably,
What's the starship made of?
I don't know. Like,
The-
What's the starship made of? One circle plus another circle. So one circle plus another circle is going to be
36.
36 pi plus
36.
36 pi. Now,
And then subtract 20.
the overlapping area says that those circles overlap for an area of 20, which means if we just add 36 pi and 36 pi, we're counting an extra 20. So we want to subtract 20. Okay?
According to my
Now,
calculations. Yes.
What is 36 pi plus 36 pi? Don't overthink this.
226.1.
No. No. Don't overthink this. Put the calculator down.
72.
What is 36 pi plus 36 pi?
36 pi squared.
72 pi squared.
How about 72 pi?
That's
Oh, okay, there you go. Just 36.
It's just, it's
What's
like
that
saying
pi
what's, it's like saying what's 36 pies plus 36 pies. It's 72 pies. We're not multiplying pies here. We're adding pies.
Whoa.
It's just like
did
a
you go to the
variable.
food? Did you go to the food or were
I
you
did.
talking about?
I
Oh,
did.
Now you're talking about
Now,
pi.
focus. Okay. 72 pi minus 20. Now, at this point, or at some point, you do have to get a calculator. Okay? You can do the calculator now, or you can save it for the probability. What is 72 pi minus 20?
It's 206.1946711.
Think I got that?
Dang, the whole thing?
I did.
You need the whole thing?
Well, here's the deal. How precise do you want your answer to be?
Precise.
Your teacher wants it to be precise. Okay, so now, in order to do the probability of the black hole landing in the starship, What are we doing? We're doing that number, right? You can either think that 206 number or the 72 pi minus 20 number divided by what?
680.
The 680. Now, if you put this in your calculator like this, you have to put the numerator in parentheses. Otherwise, you'll go astray. The calculator gives me what as a decimal?
0.303227.
Okay. I'm going to go 0.303, which is what as a whole percent?
30.3.
Or 30% is what my notes have. 30.3% as well.
30.3 is more accurate.
Okay, folks, this is a big application of area. Okay, it's kind of basic once you have the idea, but we've got to know how to do this type of stuff. Okay, this is something that you would see pop up on various standardized testing, I feel. So we have to know how to do this stuff. Okay, tomorrow we will finish up a little bit more with mutually exclusive events and rolling a pair of dice. And then we'll go talk about some independent and dependent events. Be prepared to boogie tomorrow. We got a lot to get done.